Hi, I'm Phil McCaffrey, and this lesson is on the relationship of the sides of a triangle. The question reads, the sides of a triangle are all integers. If one side measures 5 units in length, what is the least possible value for the perimeter? Well, the sides of a triangle, A, B, and C, pretty nice triangle, Phil. Doesn't look too bad. So we have A, B, and C. The rule that you've got to remember is that the sum of any two sides must be greater than the third side. A plus B must be greater than C, and it follows that B plus C must be greater than A, and so on and so forth. So if I have one triangle and the side is 5, that means the other two sides in their sum must be greater than 5. And if they're all integers, the greatest integer, the least possible integer that is greater than 5, oh, you didn't say that right, is going to be an isosceles triangle. The other two sides add up to 6 because 6 is the first integer greater than 5. So the other two sides are 6. What is the least possible value for its perimeter? 6 plus 5 is 11. This triangle looks like this. No, it doesn't look like that at all, drawn to scale. That's an equilateral. We all have a tendency to draw that one. Let's take a look at the next problem on my worksheet, and that says the two sides of a triangle measure 7 and 31. What is the greatest possible integer length for, how about a shape recognition one? So let's look at 7 and 31. What is the greatest possible integer length of the other side? Oh, that didn't complete that. So let's do 7 and 31. And now I want to come back. Does that form a triangle? No, not too good. Let's just draw one, why don't we, Phil? And that's 7 and 31. Let's put a line in there. So these are all lines, and their lengths are 7 and 31. Well, the greatest possible area as 7 plus 31 must be greater than my value, and that's 38 must be greater than 37. This side, its greatest possible length is 37. Its smallest possible length is very, very small. If it's an integer, it can be 7 plus some integer must be greater than 31. So this has to be 32. So I need 25. So 7, 31, and 25. That creates a triangle as well. Which of the following could not be the sides of a triangle? We love the not problems, don't we, on the SAT? The not problems. We could not be a triangle. Well, 1, 1, 1, that's our friend, the equilateral. 2, 2, 3 is 2 plus 2 greater than 3, and is 3 plus 2 greater than 2. Yep, that both checks out. It's an equilateral triangle. So that's a triangle, that's a triangle. 3, 4, 5, you better know that that's a triangle. That's a ubiquitous triangle on the SAT. Equilateral, isosceles, and a 3, 4, 5. How about a 2, 3, 6? 2 plus 3 is greater than 6. 5 is less than 6. That's our answer right there. 2 plus 7 is greater than 10. 9 is greater than 10. Trick question. Wanted to see if you're paying attention. I've got 2 that are not triangles. The first 3 are. The last 2 aren't. It's my multiple choice test. I can make it the way I want it. And how about this fun one? An isosceles triangle has a perimeter of 50. Two sides of the triangle measure 20 and n in length. If n is an integer, what is the difference between the maximum and minimum values of n? Well, this one is a little odd, so I'm going to draw it like this for you. Because we can have n and 20 and 20. This is just playing with isosceles. And then I could have n and n. and 20. Well, these two added together is 40, so that makes this side 10. These two added together is 2n plus 20 equals 50. Let's subtract 20 from each side. We get 30. N is going to equal 15. So in this case, we have 15 and 15. The difference between the maximum and the minimum value of n is 15 minus 10. 15 minus 10 is equal to 5. And that wasn't really why we were here. I just liked that problem, so I threw it in there. Two sides of a triangle measure 2 and 20. What is the greatest possible integer length of the third side? 2 plus 20 is 22. The greatest possible integer is 21. Very, very simple. I'm Phil McCaffrey. Happy learning.